might be a little appendix to the chapter. In an intermediate textbook, it'll be explained in gory detail, and in my textbook, it'll be explained in gory detail. And everybody gives the same explanation, except mine has a real example in there, so my example comes from a study my friend Jeff LaFrance did of electricity in Montana, and it's real. It's supposed to be made up. The primitive here is a bundle of goods. People have preferences over bundles, and a bundle of goods has some amount of all of the goods you're considering. An amount could be zero, right? Here's my example. I have a world in which there are only two goods, because I like to stay on a graph, and there are apples and green beans. A bundle is, an example is 2 apples and 3 green beans. So anytime you give me a tuple, an ordered pair of numbers, right, you're describing a bundle in my 2 space. Here, any ordered pair you give me is going to describe a number of apples and a number of green beans. So if there are n goods, then a bundle has n elements, right? So if I have an n good economy, I'm being much more general, then a bundle is a vector x in Rn, actually Rn plus, I don't have negative goods, if you like the math notation, just meaning it has a value, a non-negative value, for each of the n places. And that's a description of how much you buy of each of the n goods. And n shall never be mentioned again. We'll live in a world where there are 2 goods, and so a bundle is simply an ordered pair. It describes how much of the goods. Our question is, what bundles can a consumer afford? And I've got in mind a ridiculous world. You wake up, I've woken up, and on your dresser is money. You take the money. You go down to the store. You buy your bottles of wine and your loaves of bread. You put them in your backpack. And you walk up to the ridge just overlooking your beach. You sit down. You consume your bundle of goods. The sun sets, and the world ends. Okay? So I now have a theory world in which I've cut off a huge amount of reality, but I can stay in a simple 2 space. And I'll explain to you how I can get from there to reality. But that's my little model. It's a 1-period world, and there are 2 goods. And the way you get the 2 goods is money just appears, and you use it to buy the 2 goods. That's the simplest setup I can imagine. And I have bread and wine, and here I have a price, P for price, a subscript B to tell me it's the price of bread, and here a price and subscript W to tell me it's the price of wine. And I have the quantities, capital letters. B is the quantities of bread in loaves. W is the quantity of wine in bottles. And even though in these examples you will be allocated more than 1 bottle of wine, in real life you are never to drink 2 bottles of wine in one sitting. Never. And if someone else says you should, you say, no, my economics teacher said I may never do that. I'm sorry. I just can't. I'm going to have to go home now instead of getting really sick. You can blame it all on me. You don't have to blame it on your mother anymore. So now in my silly world, and remember I created a toy world. In my toy world I have income, and I spend my income. And that's what that equation says. It says income Y equals the price of bread times the number of loaves of bread, my expenditure on bread, plus the price of wine times my expenditure on wine. The expenditure times the number of bottles of wine. Right? I add them together, I get my total expenditure. I'm assuming something in the background. I'm assuming that you don't leave any money left over. So technically, in the background, I'm assuming something about your preferences. I'm assuming that you would always take more of at least one of the goods, and that would make you happier. So if you want to think of that as another thing I shoved under the rug, fine. It's an introductory class. You could just take the thing at face value and say the consumer spends all of his income or her income. That would be fine by me. So I've written this down. BW are the pairs that cost exactly Y. So I created a set, really, that costs exactly Y. So any pair that lies on the budget constraint costs exactly Y. Any pair that lies under the budget constraint costs less than Y. So I'm going to graph this thing, which I will do properly in a bit. But let's just draw it and talk before we go get slides. It's sometimes worthwhile. Come on, where's pen? What? Thank you. Right. So I've got in mind here bread on one axis, wine on the other axis, and a straight line. Right? And so here's an example of a pair. It really should be the other way, should it not? I drew it this way. Right? There's a pair that's exactly on the budget constraint, exhaust your income. And here's a pair that's under the budget constraint, and you don't exhaust your income. And I'm really going to just deal for a long time with the pairs who exactly exhaust your income. And I've given you my excuse. My excuse is you'd never pick a pair like this one here because you'd be happier if you bought a little more bread. And so you wouldn't pick such a pair. So that's putting the cart ahead of the horse. All right. Objections. But people don't spend all their money in one day because the world doesn't end, and so they have savings. I can deal with that. How do I deal with that? I have more goods. Suppose I have 2 days. Then I'd have bread today, bread tomorrow, wine today, wine tomorrow. I'd have 4 goods. So I can deal with savings. Obviously, I can carry that out for n. So that's not a problem. So I could have n. I could have n goods if I needed to. I could have m time periods. The model will work the same. I just won't be able to graph it. So in that sense, my model is not really that non-general. Let's go back to what grade? Slope-intercept form of a line. What grade? What? 7, you think? Yeah, or 8, something like that. Yeah. So now we need to go back to 8th grade. And what we need to do is we need to decide what we're putting on the horizontal axis, which I'm putting wine on the horizontal axis, apparently, and solve the budget constraint for W. Remember, we go back. That's your budget constraint up top. I solve that for W, and I get W is Y over P, and that's the intercept and slope-intercept form, minus PB over PW. That's the slope times B. Now I can graph the thing. If I gave you all of those pieces of information, you could write down that line for me. So you could just draw a graph. You put W on the vertical axis, you'd B on the horizontal axis. You'd mark off for me the intercept, and you would either work with the slope or you'd work with the horizontal intercept. So let's talk about how I would do this. I had it to do. I would draw, put my W, I put my B. I know that this is Y over P, W, and I can reason it from first principles. What is it? Suppose I spent all of my money on wine. How much wine would I get? Well, price of wine times quantity of wine equals all of my money. Y. Therefore, the amount of wine I would get is W equals Y over price of wine. I can do exactly the same thing for bread, which is how I find the horizontal intercept. So down here, what's this? I spent all my money on bread. How much bread would I get? I'd get that much bread. Now I got 2 points on a straight line. I would take that straight edge, which I can't use on this. This is one of the, right? You imagine that as a straight line, and I'm done. So if you're going to do these problems in an intermediate class or an elementary class like mine, and you want to get them done quickly and accurately, then you want to make this graph, and you want to choose this point and that point. And that is the fastest way to get it down without having to remember anything. You can do it from first principles. So now I have a budget constraint. So let's look at our story again here. Let me just redraw a budget constraint. Here's a budget constraint, right? Here's I got wine. Here's I got bread. And I want to have a little more wine. I'm starting at this point. I'm thinking, geez, you know, I have a little more wine. Okay, I can do that. Right? I can move in this direction up the budget constraint to this point. Well, what happens when I do that? How do I get more wine? I have to give up some bread to do it. And so the slope of the budget constraint is how much of the vertical good you give up to get 1 unit of the horizontal good. That's the meaning of slope here. So it's the trade-off that's offered to you by the market. The relative prices of goods are the trade-off the market offers you between the two goods. You get a little more of this one, but it's going to cost you so much of that one. That's what the market's doing. It's offering you this trade-off. So here I've drawn an example, which I'm going to use quite a bit. And I want to know what you can find from this if I had just the line. Right? Can you tell me anything about this from just the line I drew? I don't know anything else. I just see this picture. What can you tell me? Can you tell me income? Can you tell me PB? Can you tell me PW? Can you tell me the ratio of PB to PW? What can you tell me? So you can tell me the what? But you can tell me the ratio, right? That's all you can tell me is the price ratio, because that's the slope, and you can read the slope off. I mean, you go down 100 and over 25, right? So the slope of the line you can read off, and you know the slope of the line if you went back a couple of slides in terms of PB and PW. So you give me the price ratio. You can't tell me anything else, can you? But if I told you one more fact, you could tell me everything. The most convenient possible fact is PW equals 1. It's just the most convenient possible fact. So if PW equals 1, what's Y? 100, yeah. What's PB? 5, right? Y is 100. Y divided by 5 is 20, right? So you can decode the whole diagram just like that. I'll give you just one more fact. But the diagram by itself just gives you the relative prices. PB is 5 times PW. That's all you can learn from just looking at the diagram. Okay, so now you get to play around a little bit with that picture. So what do I want you to do? Show what happens if the price of bread increases to twice its previous value. So I want you to take the original picture, draw it. Remember, you're just doing a sketch. There's no need for accuracy here, right? I'm doing it on the board. Right? This is Y over PB. This is Y over PW. And I'm asking you, suppose PB is now suddenly 2PB instead of PB. What happens to this picture? So draw this and then draw the picture with the price of PB twice. Okay? Yeah, you're actually going to do this. Because if you can do this, then you can answer all the exam questions. You all end up looking brilliant. And there's just nothing like actually doing it. So just to go back a second, here's the original slide, right? So through 120 are the two things. Price PW equals 1. And now I want you to show me what happens to the line when PB doubles. I'm just going to kind of watch when people stop drawing, or enough people stop drawing, I go on. I can only see the people in the front, by the way. In the back, you could be doing anything. I can't tell. Maybe playing bridge on your iPads. I have no idea. Maybe someday I'll walk back there and find out what goes on in back row life. Yeah, you done? Generally done? I don't hear any murmurs to the... Okay, so now, same graph. I want one more line. I want you to pop income up to 120, but leave the prices where they were at 1 and 5 and 1. Original prices. So here's your original line. Leave these two prices alone and take this income guy and make it go up. And just, I want to go to 120, so if you're drawing it accurately, it goes up by about 50. I don't care. Just make it go up. So I want you to draw a line. Yeah, you're done. You should be done. Why should he be done? The slope of the line is given by what? The ratio of the prices. Did it change? So you're drawing a parallel line, right? So we should be done here. And then it would be best if you drew a third diagram. Start off with your original Y over PB, Y over PW, and now leave PB the same and take PW up, just for completeness. This diagram should have one more line on it. So it should look almost like the first one you did. Just different things going to shift. So I should draw these. Why don't I draw it on top of here, okay? So if PB doubles, how much bread can you buy if you spend all your money on bread from this diagram? Which is half, agreed? PW stayed the same, so Y over PW stayed the same, so the intercept stayed the same. I got two, right? It's my new line. So basically it rotates in. I'm going to use that eventually to create a demand curve, so I care a lot about that. Next example, you already know if I don't change the prices and I do change income, that I will get a parallel shift. What I've drawn here is Y over PW, where PW is 1, is 100. I asked for Y to be 120. So now I'll get the intercept of 120 divided by PW, 120 divided by 1, or 120. So I come up here. And you could work out exactly where down here, but I just by eye, I'm just going to draw a parallel line instead of parallel. And call that good enough. But you could, in fact, find that out, couldn't you? So the price is 5. The income is 120. What's the intercept going to be? 24. Right? Because 24 times 5. Yeah? So you could actually work it out. Those are all the reasonable things you can do. There's some unreasonable things you can do. Here's an unreasonable thing for you to do. And I don't think I'm going to do it in class. I think I'm going to let you take it home and play with it a little bit. And next time, I will come back to it. But I think it's really worthwhile for you to take this slide and try to draw the diagram that goes with it. This is worth about 20 minutes. If you can do that, you can do any of these exercises. This would be an exercise you would give of, say, Econ 101A, the mathematical version of intermediate theory. And I know because that's where I got it from 40-some years ago. So you can go find that and play with it a bit. So we've got budget constraints. Got everything we need to know about budget constraints. Any questions about budget constraints? We good? Budget constraints describe what you can buy. They're our description of reality. Now we move on to preference. Preference is a lot more subtle. It's a description of you. So each consumer has different preferences. I'm sure of that. I do not believe that you will find 2 consumers in this room with the same shirt. Correct? I could have bought the shirt with the stars on it, but I didn't. I bought the dull shirt. So my preferences must be different. And if you look around, there's a huge array of goods in the world, and people with some very similar incomes are making very different choices. It's not about, I came from green shirt land where I was forced to buy green shirts. It's about, I just didn't pay attention and I got a green shirt. I mean, my preferences were for a green shirt. So we all have different preferences. I can't say consumers have preferences, meaning all of them have the same. They don't. They're wildly different. We're going to start by dealing with only one consumer. And then we'll go from our one consumer's preferences to his choices or her choices. And then we'll get a demand curve by changing the prices around the way we just saw. And at that point, we can add the demand curves for many different consumers. And then we're done. We're into the market world. So preference describes what a single person does. We make an assumption. This is our behavioral assumption. It's not an observation about reality. This is not, we simplified reality a little bit, but it's good enough for our work. This is a behavioral assumption. And our assumption is people do what they want. People do what they want to do within the constraints imposed on them by reality. So we assume people make choices. And those choices are the best thing for them. And that's got a lot of content to it. We will examine where you might think it's silly. So I'm going to bring up examples to push the boundaries on whether or not you think that's a good assumption. I think it's a great assumption for whether people decide to have hot breakfast cereal or cold breakfast cereal. And most of the goods that I trade in ordinary markets, I think it's a perfectly good assumption. I'm willing to live with it. And you'll see where I'm not so happy. So we're kind of axiomatic here. We went through this period where we thought math was going to save us. It didn't. And in that period, we took everything we knew and we wrote it down in primitive mathematical terms. And I came from that period, so I impose a little bit on you. And our statement about preferences can be written this way. People have preferences over bundles. Remember, a bundle is the amount is an n tuple stating the amount of each of the goods. So I have preferences over these n tuples. I don't have preferences over oranges. I could have preferences over a bundle that had oranges and BMWs in it, but to say I have preferences about oranges per se makes no sense. I already know I like more oranges rather than less. What's to discuss? So you can't say preference for a good. You have to say preference for a bundle and build that into your speech, because if you always say preferences for bundles, you've got most of these problems a third of the way solved. People have preferences over bundles. What does that mean? It means there are 3 possibilities. You got 2 bundles, bundle A, bundle B. I can say I like A better than B. I can say I like B better than A. I can say I like them both the same. And those are the only possibilities. Different people will have different answers to that question, confronted with 2 bundles. For instance, confronted with the dish that your older sibling made, 2 dishes, one of which has a lot of cake and very little ice cream. The other has a lot of ice cream and very little cake. The 2 siblings can prefer different dishes, and often do. And a mean older sibling who knows your preferences can set it up so they get the majority of everything, and have them divide and you pick, if you think about it. You don't like ice cream, and you do like cake. They can take almost all the ice cream and pretty close to half the cake, and still have you pick the bundle with a little bit more cake. And they would end up with all the ice cream and just under 50% cake. People can have different preferences over bundles. They have. What don't we allow? We don't allow teenagers. What's a teenager? You don't know anymore, right? You're all done with that. So when a teenager's parents ask, where are you going? What do they answer? Out somewhere. Who are you going to meet? Someone. And so on and so forth. And do you want this or do you want that? What are they going to say? Don't care, right? The teenager's going to try to impress on you that they don't have preferences over the 2 bundles that the parent has offered. So we rule out teenagers. You must have preferences. It's okay for your preference to be, I like the 2 exactly the same mother deer, with much sarcasm in the voice. But it's not okay, really, in terms of this model, to have someone who actually has no preferences. They must be